Hello my dear students, this is a very small video. Here we are going to learn what is conservative force, what is non-conservative force, and definition of law of conservation of mechanical energy. Here in this video the explanation will be a little less. You have to write the definitions, okay? That is very important. Conservative force, what do you mean by a conservative force? A force is said to be conservative, okay, if work done by the force in moving a body depends only on initial and final positions, and not on the path followed. Okay, if the work done by the force, if it depends only on initial and final points and it is independent of the path followed, then such force we call them as conservative force. Okay, so conservative forces. Okay, I'll just give an example. Okay, so here there is ground, here there is a ball. This ball is lifted to a height h. Okay, now the ball is here. Okay, now what is work done? Work done equal to force into displacement, correct? Now force into displacement. So work done into cos theta, fx cos theta, correct? Now you applied force upwards, displacement is also upwards, so what happened? Angle between force and displacement is 0 degree, cos 0 is 1. So what is F? How much force you have to apply on the ball? It should be equal to weight of the ball, mg, into what is the displacement, h. So work done is mgh. Now same ball, if it is lifted upwards in this path, to the same height, okay, height is same, the ball has reached the same height. Okay, the ball has to be shifted to the same height but different path. Now see, work done in taking the ball from this point to this point is 0. Why? You know, when the ball is here, you are applying force upwards, correct? Now, because you should not allow the ball to fall down, means you have to apply the force upwards. And the displacement is in this direction. What is angle between force and displacement? 90 degree. What is cos 90? Cos 90 will be 0. So here, from this point to this point, work done is 0. From this point to this point also work done is 0, because you are lifting the ball up. Displacement is in this direction, correct? Now, so these two, the work done is 0. So therefore, this same this line can be shifted here, na? Then what you get? You get the same height. Displacement height is same. So what happens here also? Work done is equal to mgh. What does it mean? Work done is independent of path. Work done depends only on initial position and final position. Where the ball has gone is not important. Where was the ball initially? Where is the ball finally? That is important. Then such a force, we can call it as conservative force. Therefore, gravitational force is a conservative force. Gravitational force is a conservative force. There is one more property of a conservative force. What is that property? Work done in a cyclic process, work done in a cyclic route is equal to 0. What does it mean? Say for example, a ball is taken to a height h, okay, and if it is brought back to the initial position, what is the total work done? In taking the ball up, work done is mgh, that we have calculated here. While taking the ball down, this is very important. While taking the ball down, say the ball is here, I am taking the ball down, very important. Even though I am taking the ball down slowly with constant velocity, I am not applying force downwards. I am applying force upwards only. Otherwise the ball will fall down, na? Correct, na? So while taking the ball down, I am applying the force upwards only. Otherwise ball will fall down, correct, na? So displacement is downwards, I am applying the force upwards. Okay. So what happens? That work done will be equal to minus mgh, because you are applying force upwards, displacement is downwards. Okay. So what happens? So that work done will be minus mgh. So what will be the total work done? Total work done will be 0. Okay. If you don't understand, I'll explain in terms of gravitational force. Okay. say the body is taken to a height h. Okay, the ball comes here. What is the work done by gravitational force? When the ball goes upwards, gravitational force is downwards. Gravitational force is always downwards. Displacement is upwards. Correct now? So what happens? F into x. Correct now? F into x. Or F is equal to mg. We know it is mgh. No. So here we have made a mistake. Fx cos theta. Correct now? Fx cos theta. What is F? F equal to mg. Okay, x means h only. What is cos theta? Is -1. So I got minus mgh. In taking the ball up, the work done by gravity is minus mgh, because gravitational force was acting downwards, displacement is upwards. Okay. In taking the ball down, work done by gravity, in taking the ball down through a distance, through a displacement h. Now displacement is downwards, gravitational force is also downwards. So therefore what happens? Force into displacement, mgh. So this is plus mgh. Correct now? Answer is plus mgh. When taking the ball upwards, the work done by gravity is minus mgh. While taking the ball downwards, work done will be plus mgh. So what is the total work done? Total work done is equal to 0. So if the work done in a cyclic process is 0, then we can say that it is a conservative force. It is a property of conservative force. Okay, if a force is said to be conservative, work done should depend only on initial and final positions, and it should be independent of the path followed. Okay, then we can conclude that the force is a conservative force. For example, gravitational force is a conservative force. Electrostatic forces are conservative. Okay. Now, what are non-conservative forces? A force is said to be non-conservative if work done by the force in moving a body from one position to another depends on the path. Okay. Friction is example for non-conservative force. Why? If there is a rough surface, work done by friction is more. If there is a smooth surface, work done by friction is less. If the work done by force depends on path, then it is non-conservative. Frictional force is non-conservative because force of friction depends on path. Or viscosity that you study later. Okay, that is also non-conservative. Now we will see, we'll study something called law of conservation of mechanical energy. Okay, mechanical energy and its conservation. What is mechanical energy? Mechanical energy is equal to kinetic energy plus potential energy. Mechanical energy is equal to kinetic energy plus potential energy. Okay. The total mechanical energy of a system is conserved if forces doing work on the system are conservative. In the case of conservative forces, sum of kinetic energy and potential energy of a system is constant. Means if you drop a ball, when the ball is at the highest position, okay, potential energy is maximum, kinetic energy is 0. You drop the ball. When you drop the ball comes down, potential energy decreases because what is potential energy? Potential energy is mgh. As h decreases, potential energy decreases. When the ball reaches the ground, potential energy becomes 0. But as the ball comes down, speed of the ball increases. So kinetic energy of the ball progressively increases. When the ball touches the ground, kinetic energy will be maximum, potential energy will be 0. But anywhere in between, anywhere on the path, if you add kinetic energy plus potential energy, the value is always a constant. Okay. Total mechanical energy means sum of kinetic energy and potential energy of a system is constant if forces doing work on the system are conserved. This is called law of conservation of mechanical energy. Okay. In the next session, we are going to prove law of conservation of mechanical energy. Okay, principle of conservation of mechanical energy in the case of a freely falling body, and that is an important derivation. Hope you understood the concepts: conservative forces, non-conservative forces, examples, and what is mechanical energy, what is principle of conservation of mechanical energy. Okay, thank you very much.